Today we'll be looking at the cosine rule, which is another type of rule that we can use for non-right angled triangles. So the cosine rule's named this way because in the equation there is a cosine in it. So it's used when we've got three sides and one of the angles. So just another reminder, when we label a triangle, we label the corners with capital letters A, B, and C. But then when we label the side opposite the corner A is little a, the side opposite corner B is little b, and the side opposite corner C up the top is little c there. And the relationship between the three sides, A, B, and C, and a particular angle is this formula here. So in this formula, I've started with c squared. Okay, it's a squared plus b squared minus 2 times a times b. So those are the sides and the cosine of c. So what you'll notice is the c squared is at the front and we have a cos c in the back. Now this is in order to find the angle c. We could also go and rearrange this equation to find corner A or corner B as well. So how we can do that is we just need to rearrange, like mix up the letters. So if I want to find side A, I can start with A squared. Then what that means is at the end, I'm going to have the cosine of A. So then we fill in the blanks. So then that will be B squared plus C squared minus 2BC cos A. And that means exactly the same thing. I think your textbook uses this formula, but I do prefer the C version. That's also the one that you will be given in an exam. If we wanted to find side B, then if we rewrite that, B squared, and then we've got cos B, so then the equation will be A squared plus C squared minus 2AC cos B. So that would be how that the formula will look. The proof for this is using Pythagoras' theorem. So we want to go back to right angled triangles, but we can also work with right angled triangles and cosine because we needed to find a perpendicular. So what happens here is we cut our non-right angled triangle into two right angled triangles. If I call this section X, and then this section is going to be B minus X because the whole thing was side B. The perpendicular here we've just called H, and we're going to relate all this to that angle C in there. So if I look at that little triangle here, then we have A squared equals to X squared plus H squared. It's just Pythagoras. Or we can write the height squared is A squared minus X squared. Okay, so that's the version that we want to work with. If we look at the other triangle and we work out a Pythagoras theorem for that, then we've got C squared equals B minus X squared plus H squared. And so when we rearrange that, H squared is C squared minus B minus X all squared. Now, because both of them are equal to H, we can solve those simultaneously and put that together. So if we substitute that together, we've got A squared minus X squared is C squared minus B minus X squared. If I go and expand that, that's what we get. And you can see that those two minus X squareds are going to cancel. So what we've got left is A squared equals C squared minus B squared plus 2bx. Now that x is going to be an issue because we didn't start with that x. So what we do is we go back to that little triangle, which I've drawn here, and what we can see is if I want to find that length, I can write that in terms of A. So if that's the angle that we're looking for, cosine of C is x over A, so x is A cos C. So what we can do is we can replace x with A cos C, and that's how we end up with that formula. Now, you don't need to know the proof of it, but it's well worth knowing where it's coming from, so it's not just a formula that you're memorizing or like just using without any understanding of it. So let's have a look at a couple of questions now. So if we wanted to find the pronumerals for these cases, okay, C squared is opposite cosine of C. So you can see there's the angle and the side opposite is M. So the thing that we're looking for is going to go at the front, and we do have the angle that we needed at the back. So angle, there's the side. So when we take c squared equals a squared plus b squared minus 2ab cos c, and we substitute these values in, we get m squared equals to 16 squared plus 20 squared minus 2 times 16 times 20 times the cosine of 42. Now, so the 16 and the 20, it doesn't matter which order you put them in, because in the end, if you're adding these two squares, okay, it doesn't matter the order. If you're multiplying the 16 and the 20, that doesn't matter either. So when you put that into the calculator, we get 180.387 thereabouts. To find m, we need to also square root. Make sure you don't forget to do this, because a lot of students will stop there and think, okay, I've got the right answer, but they forget to square root. Happens quite often. So we're going to square root 180.387. Make sure you use the answer button on your calculator. Okay, so just go square root answer equals, because if you round it off too early, it could come out as a rounding error when you write your answer out. So then when we calculate that, it's 13.43. So depending on how much we wanted, we wanted one decimal place, so that's going to be 13.4, whatever units we were using. We can also use the cosine rule for an obtuse angled triangle. Okay, so even though it's an obtuse angle, it still works. Okay, and we're just going to put it in exactly as it was. So I've written the formula up here, so I'm not going to rewrite it. Okay, you might want to rewrite it just so you can practice it. It is on, we will give this to you on like a reference sheet or a formula sheet each time. Okay, but back when I was at school, we didn't really get that, so we had to keep writing it out so we could memorize it. So when we put this in, there's the side that it's opposite. So x squared is 1.5 squared plus 2.8 squared minus 2 times 1.5 times 2.8 times the cosine of 125. Okay, so we're going to put that into the calculator. So when you put that in, just be careful with those decimals. We get 14.908, repeat with some extra decimal places, and then we need to make sure we square root it. So then when we square root, again, use the answer button, and we get 3.9. Okay, now a really good way of double checking that your answers are correct is having a look at the triangle. So if we go back to A, this triangle had a side of 16 and a 20. If you had a side of 180, you can see that that's not going to make sense, because you can't have a side of 180 with a 16 and a 20 on the other two sides. So that's a really quick check that you can make of your triangle to make sure your answer makes sense. Likewise, in the B, we had 1.5 and 2.8, so that 14 isn't going to make a triangle, so we needed to square root it. So it's just making sure we remember these things. What we're also going to look at is how we work out an angle using the cosine rule. Now, if we go and take the original formula and we rearrange it, it actually comes out to be this version here. I'll show you here really quickly. C squared equals A squared plus B squared minus 2AB cos C. So what we're going to do is we're going to, because that's negative, I'm going to move that over to that side, and I'm going to move the C squared over here. Okay, so we're adding the 2AB across, so 2AB cos C equals to A squared plus B squared minus C squared. Okay, so all I did was swap those around so that I could get a positive for the cos C section. What we can then do is take the 2AB, divide it over, and you can see that's going to be the formula. A squared plus B squared minus C squared over 2AB. So how we use this is, if we're looking for the angle C, okay, the order that we have, the numerator has to have a minus C squared. Okay, so again, when we're looking at the triangle, work out what's the side and the one opposite it, and then we're putting it together. So if we look at this first triangle, there's our angle, there's the side opposite it, so that's going to be the C, and that's going to be angle, and theta is going to be angle C. Okay. So cos C is a squared plus b squared minus c squared over 2ab. So what we've got there is 3 squared plus 3 squared minus 2 squared over 2 times 3 times 3. And so when we work that out, that's a fraction that's about 7 over 9 in your calculator. Then to work out the angle, so cos theta, sorry, because we've used another letter, a pronumeral. So to work out theta, we need to get rid of cos, so it's inverse cos minus 1, 7 over 9. When you put that into your calculator, you get 38.9 degrees or thereabouts. So that's going to be 39 degrees to the nearest degree. When we look at the second triangle, there's the angle. That's the side opposite it. So again, cos C is a squared plus b squared minus c squared over 2ab. Cos theta is 8 squared plus 10 squared minus 15 squared over 2 times 8 times 10. So when we go to work that out, we actually get a negative value here, negative 61 over 160. So remember what we did earlier with our quadrants. If cosine is negative, it means that we're in either the second or the third quadrants, which means we either have an obtuse angle or a reflex angle. But when we're looking at a triangle, we can only have acute and obtuse angles. So that means that we're looking at an obtuse angle. So when we go to put this into the calculator, we don't need to do the quadrant stuff. All we need to do is put this exactly as it is into the calculator. So cos minus 1, and we're going to put negative 61 over 160 into the calculator. And your calculator will actually give you an obtuse angle straight away. So you don't need to do any of the 180 minus or any of those things. So when you work that out, it's 112.4 to the nearest degree is 112 degrees. Okay, so even if it's obtuse, we just put it straight in. The sign that you know it's obtuse is going to be a negative cosine value. Okay, last thing. If I gave you the information in words and I didn't give you a diagram, always draw a diagram first. So this one, we've got triangle ABC, and we have side AB, BC, and CA. So we've got 3 sides, okay? We need to put all that information together. Now for these sorts of questions, just draw any triangle, okay? Try not to draw a right angle triangle, because then that could confuse you, because you might think that there is a right angle when there isn't. So triangle ABC, just label the corners, any order, A, B, C. Now side AB is 5, BC is 7, and CA is 9. So there's your 3 sides. Now we need to work out what the largest angle is. Now the largest angle, okay, I'll just tell you as a rule, is always opposite the longest side. Okay, it sort of makes sense. If you've got a really short side, then the angle opposite it will be a very small angle. So what in this triangle, what we're looking for is this angle right here. So I'm just going to label that theta. Okay, and that's the diagram that we're working with. So there's our angle, there's the side. So cos C equals a squared plus b squared minus c squared over 2ab. Just be careful when you're looking at the formula, because in this triangle, that corner's become b, okay? So when you're saying c, okay, you need to know what you're actually talking about. So if I substitute the values in, cos theta is 5 squared plus 7 squared minus 9 squared over 2 times 5 times 7. When you put that into the calculator, you get negative 1 over 10. So to work out the angle, just put cos minus 1 of the fraction in, and you get 95 degrees, and rounded off is 44 minutes. And that would be the answer there. So if you could have a go at those questions in 7H, okay, and see how you go with those.